Today's the 23rd. Okay, so we have sine x plus y minus sine x minus y. Everything divided by cosine x plus y and plus cosine x minus y equals tangent y. Obviously, I will start from the left-hand side. I will expand this because there are two different formulas. I will expand these two. They're two different formulas. And so the left-hand side. So I have sine x cosine y plus sine y cosine x minus sine x cosine y. I should write minus, but there is a minus in front.
Yeah.
So I will put plus sine y cosine x.
Oh, yeah.
So now the denominator is cosine x cosine y, but minus sine x sine y plus cosine x cosine y and plus, this is the only one with twisted symbol, plus sine x sine y. And if you look carefully, you'll see two terms go away at the top. The sine x cosine y with a negative in front and the sine x cosine y with a positive in front. So then the top is 2 sine y cosine x. And then two terms go away in the denominator, the positive and the negative. And then we have 2 cosine x cosine y. Only in this step I can simplify because I simplify factors.
Yeah.
I could have not done anything before because there were terms. So the cosine x goes away with the cosine x from the bottom, and I write 1 and 1. 2, bless you, 1 and 1. And then what's left is sine y over cosine y, which is tangent y, and that's exactly what I have on the right-hand side.
Yeah.
Okay, anything else from this test? Is there anything else left that we haven't covered?
There's one with the half of the formula on
Which number?
it. 12.
Number 12. Okay, let's take a look.
12.
Okay.
Half of them.
Okay.
Somewhere different.
Okay, so we have cosine pi over 12. Exactly using the formula for sum or difference or of angles or half angle formula.
Right.
In order to use a sum or a difference, of course, it's going to be a difference, it's a tiny angle. Then I have to see what pi over 12 is. That's one option. The second option, if you'd like, this one I prefer because it's so much easier than having to dig deep. So pi over 6 divided by 2 means pi over 6 times 1 over 2. So when I divide a fraction by a number, I'm really, in my head, multiplying it by 1 over.
Yeah.
So that's why pi over 6 times 1 over 2 is pi over 12.
Right.
So I know what this is. First of all, it's a tiny angle. It's in the first quadrant. And I have the square root of 1 plus cosine pi over 6 over 2. This is a very important formula to remember. And it's done, basically.
Oh, that's it?
Yeah, because I just
Oh,
have to
okay.
replace cosine pi over 6.
Oh.
So how much is cosine pi over 6?
That's the 1/2. Sorry.
That's for sine.
Square root of 3.
Yes. The square root of 3 over 2, everything over 2. So this is the square root of 2 plus the square root of 3 over 4 because I have to flip. So it's 2 plus. So it's the square root of 2 plus the square root of 3 over 2. And that's it. That's all I needed to do. We were asked to find cosine pi over 12 exactly. You can always punch it in the graphing calculator to check and make sure that you use the correct formula, the identity, I should say, and so on and so forth. So you'll punch in the calculator cosine pi over 12, and you'll punch in the calculator this expression,
Right.
and see that they are the same. And they are the same.
Yeah.
Any questions on this? This was problem 12 on the
Yeah.
And we also did the previous problem, the trig identity. So
Okay.
we expressed these two, and we simplified, and we ended up with sine y over cosine y, which is tangent y. Good. Anything else? Nico, anything else that you wanted to look at? Anything else you tried or anything? Paul said he would be here early to ask questions.
Did we do number 13?
I don't remember. No, I don't think we did 13.
Okay, do that one.
Yes, let's do that.
Okay.
So cosine to the fourth. Obviously, it's just cosine squared, everything squared. And this one, it's the same thing I used here, without the square root. Okay, very important formula. So 1 plus cosine twice x divided by 2, everything squared. Now I have to square the top and the square the bottom. I will keep 1/4 outside, it can wait. And now when I square a binomial, I have to remember to write 3 terms. The first term squared is 1 plus 2 times the first times the second. Here he comes. And plus the second term squared. It is wise not to distribute 1/4 in here till you change this. Although it's not such a big deal. It's such a big difference. Because I'm not going to change this, but I prefer clearing everything, every power for cosine or whatever I have. In this case, it's cosine. And then at the very end, distribute 1/4. So I will have to replace this now. And I do this. So it's 1/4, 1 plus 2 cosine 2x plus 1 plus cosine 4x over 2. I will still keep 1/4 outside. I will find the least common denominator inside and make the necessary changes. This one changes into a 2. This one changes into 4 cosine 2x, and then I copy the rest. Plus 1 plus cosine 4x. I combine like terms at the top, and I get a 3 plus 4 cosine twice x plus cosine 4x. And now I'm done. 2 times 4 is 8. Yes, you can separate it into 3 fractions if you want. 3 over 8 plus 4 over 8, which is 1/2 cosine twice x plus 1 over 8 cosine 4x. As you see, these are involving, even if they're just only cosine to the fourth. Require a lot of work. Okay. Anything else that you would like to go back to from this test? Paul, anything you have for me?
I had something small that probably. I think I was working some integral equation and the answer in the book was different.
Okay, let's take a
I'll
look.
get- I'll
Oh,
get
yeah.
it right.
Let's take a look. I am going to give the test on Wednesday. Is that okay? Is it too late? Because
Give it to the testing
to the
center.
testing
on Wednesday?
center? Yeah.
Oh, okay.
That's fine.
Is that okay?
Mhm.
Because tomorrow I'm at Arundel Mills, but I can.
Oh, okay.
I'm at the Arnold campus Tuesdays and Thursdays. I'm
Yeah.
at Arnold.
That's fine.
Okay.
We can do it through Saturday, right?
Yes. Yes. And on Wednesday, I will bring you the test 4 that you have to
Okay.
turn in. I know. I know. Yes, Paul.
Yeah, so the question I had may not be super complicated, but 1 plus cosine y over,
Everything over?
yes, 1 plus secant y. And this is just a simplified.
Simplify. Okay, very good. Awesome. So there is nothing I can do to the top. 1 plus cosine y. And the bottom, it will be 1 plus 1 over cosine y, because I have to change secant into 1 over cosine. I leave the top alone, and the denominator has to have one denominator. So this is cosine y plus 1. I'm going to write it as 1 plus cosine y. The top is 1 plus cosine y over 1 multiplied by, flip this into cosine y over 1 plus cosine y. Assuming all conditions are fulfilled, I can do this. And therefore, the final answer is just cosine y. Is that okay?
Yeah, because I think where I went wrong was I got most of it, then when I flipped, I did 1 over cosine y, which I think was where I went.
You mean from here you cannot flip yet?
No,
you have-
from over there.
Here?
Yeah. Because there's,
But is it clear now?
yeah,
Yes? Good. Other questions for me? Anything else? Is there anything else? I know you can still ask on Wednesday, but let me know. Anything else? Okay. Ready then? Anything else? Anything else, Paul? Okay, so let's look at the 11.3 hyperbola. The hyperbola is here's a geometric definition, very similar to the geometric definition of the ellipse. Same idea, but not exactly the same. So the hyperbola is, of course, not a function. It's two functions, this function and this function, right? So this time, any point on the hyperbola has the distance between the furthest away focus minus the distance between itself and the closest focus, the same or constant for any point anywhere on the hyperbola. So this time the difference between d1 minus d2 is the same. So, and that's how they developed the equation of the hyperbola, which will be x squared over a squared minus y squared over b squared equals 1. If the hyperbola has the major axis on the x-axis, how it will look like if its major axis is on the y-axis. It will be y squared over a squared, but minus x squared over b squared equals 1, and this will be on the y-axis. So not difficult to identify. The one with the plus dictates the major axis. The hyperbola has two foci, like the ellipse does. And let's look at an example in which we will find the vertices. The major axis is called the transverse axis here. Okay, the foci, the same, plus or minus c comma 0. And this time, c squared is a squared plus b squared. So f1 plus or minus c comma 0. I should say f1 and 2 plus or minus c comma 0. And c is calculated differently. Okay. Very similar to the ellipse. On page 748, let's practice some graphs and finding the characteristics of the hyperbola and so on and so forth. Okay, so let's look at match the equation with the graphs labeled 1 through 4, if you'd like to pick a problem from there. Then 9 through 20. So we're on page 748. And we're looking at 5 through 8, 9 through 20, 21 through 22, 31 through 42. Okay, I'm going to choose the first one if you don't want to. I'm going to choose 8, in which we have 9x squared minus 25y squared and equals to 25. And I don't really want to look at those graphs. I just want to analyze the hyperbola, and then at the end go back and look and say, oh yeah, it's number blah, blah, blah. So first step, I have to do what? In order to find the equation of this hyperbola. That's it. So I have 1. So 9x squared over 225 minus 25y squared over 225. So I'm going to try and divide 225 by 9. Do we get anything specific? And I'm going to divide 225 by 25 and see if I get something specific. So 225 divided by 9.
25.
Okay. And 225 divided by 25 must be 9. Very good. There is no question now that the hyperbola has the transverse axis, if you want major transverse axis, on the x-axis. Why? Because this term with x squared has plus. This term with y squared has minus. Okay. So then this is a squared, which is 25. So then a will be 5. And you can say, why don't you write plus or minus? I will, in the sense that a is 5, but I will find a positive and a negative. And then b squared is 9. So then b equals 3. Here's how I graph the hyperbola. First, I have to graph a center box. Here's how. A is on the x-axis, so I have 5 to the left, 5 to the right. B is on the y-axis, 3 and 3. And with these 4 points, I draw a rectangle going through these 4, all of them. That's my first step, the center box. Then I have to graph 2 asymptotes. Please pay attention how we graph the asymptotes. They have to go through this corner of the box through the origin and through this corner of the box. That's the first one. And you will give me the equation of this in a blink. And then the other one has to go through this corner of the box to the origin and the opposite corner of the box. And you will give me the equation of that. Because I know you can. We haven't graphed the hyperbola yet. I also would like to determine c. C squared equals a squared plus b squared. So c squared is 25 plus 9. So then c squared equals 34. And c equals the square root of 34. So therefore, you will tell me what is f1, what are the coordinates of f1, and what are the coordinates of f2.
Square root of 34 is 0.
Yes,
Negative.
that's it.
Square root
So negative is square root of 34, the square root of 34, and 0, 0, because they both foci have to be on the x-axis. Very good. Okay. Can anyone give us the equation of this line? Can anyone give us the slope, first of all? So indeed, 3/5, right? 3/5. And since it passes to the origin, it must be 3/5 x. Very good. Now, can anyone give us the equation of this ellipse? I'm sorry, of this asymptote? Right. Okay, ready? Now we're ready to graph the hyperbola. Ready? It has to go through this point. It has to go through this point, and it has to come asymptotically towards its asymptotes. Approach the asymptotes asymptotically, getting closer and closer. My graph is not perfect. Sorry about that. This is the hyperbola. And now we can go back to the graph, to the 4 graphs that we are given, and identify which one it is. Is it 1, 2, 3, or 4?
1.
Well, obviously it cannot be 3 or 2 or 4 because these have the transverse axis on the y-axis. So it has to be one or the other. So I count this is 2, 3, 4, 5. Yes, it passes to this point. And this is 1, 3, but obviously it's not this because this is 2 and this is 2. So it must be the graph in 1. Okay, good. Next problem. Well, let's choose from 9 through 20.
How about 20?
Okay, very good. 9x squared minus 16x, so this is 20. 9x squared minus 16y squared equals 1. Very good. So obviously I have 1 on the right-hand side, which is good. But I can't have 9x squared or 16y squared, so I have to rearrange it as in this way. Because when I divide by 1 over 9, I'm multiplying by 9. When I divide by 1 over 16, I'm really multiplying by 16. So therefore, since x squared has plus and y squared has minus, again this is a hyperbola that will have the transverse axis on the x-axis. Okay, so then a squared equals 1 over 9, or a equals 1/3, and b squared equals 1 over 16, in which b equals 1/4. Yes.
Why was it 190 again?
Because the equation requires 1 x squared.
And why is it on the, so it's on the x-axis?
Because when x squared is positive, it will be on the x-axis.
Oh,
If these are reversed,
okay, y squared.
and y squared is positive and x squared is negative, then it will be on the y-axis.
Gotcha.
Okay, so we are asked here to find the vertices, foci, and asymptotes of the hyperbola and sketch its graph.
Because what we're trying to do is always get one on the right
Yes.
side.
Yes.
Okay.
Yes. Both equations of the ellipse and the hyperbola, let me refresh your memory on those. So the ellipse is x squared over a squared plus y squared over b squared equals 1.
All right.
Without 1, I would not be able to identify major and yes, and
Okay.
minor axis. And in this case, we have this. So without the 1 here, I will not, same thing.
Right.
So the only difference is that one has plus and one has negative. That's the only difference.
Okay.
Well, of course, a lot of other differences I should not have said, just the difference when it comes to the equation, because the graphs are very different. Okay, so back to, it's going to be very difficult for me to graph a vertex of 1/3, comma 0, and a vertex of 0, comma 1/4. So 1/3 is bigger than 1/4, so bear with me. I'm going to say that this is 1/3 and this is 1/4. It's not. But these numbers are kind of difficult to work with. So this is the center box. I have to draw the asymptotes. And please give me the equations of the asymptotes. Y equals and y equals. Yeah, I have 1/4 times 3/1. So it's going to be 3/4 x.
Because 1/4 over.
Yes.
1/3.
So yeah, this is 1/4 over 1/3. And obviously the other one is negative 3/4 x. Now I have to find c squared, which is a squared plus b squared, which is a mess, because it's 1/9 plus 1/16. So 16 plus 9, luckily, it's 25. So when I take the square root, but I have to multiply these.
Yeah.
But I still have to take the square root, so it's going to be 3 times 4. So the denominator will be 12, and the numerator will be 5. So c squared equals 15 plus 9, 25/9 times 16, because it's a product. So then c must be 5 divided by 3 times 4. So then the coordinates of F1 and F2, they are on the x-axis, which means the y-coordinate has to be 0. Joy, any questions?
No.
If you see something, you may be right. I'd rather go back and check.
Oh, maybe.
Can
I
you
got a
explain-
different answer.
Okay, on which one?
9 times 25 over 9 times 16. 9 times 16 is 144.
Yeah, but I still have to take the square root, which is 12.
Oh, right.
Because I have to find
Yeah,
C.
it's square root.
That's why I didn't multiply, because I was lazy.
That's
I took the square root from this and I got 3, and I took the square root of this and I got 4, and I multiplied it.
Yep.
Because it's a product. Otherwise, I would have not been able to do this.
I was forgetting this.
That's okay.
Question about the
Yes?
F1 F2. You said why is it 0 on the y?
Because the foci have to be on the x-axis.
Okay.
And on the x-axis has y equals 0.
Mhm.
So what are the coordinates of the foci for F1?
Either 5, 12, 5, 4.
Very good. So this is definitely more than 1/3. So, but
Yeah.
I'm going to say here. This is F1. This is F1 and this is F2. But the hyperbola does not pass through the foci. right? It passes through the vertices here. So here's the graph of the hyperbola. So they were asking us to find the vertices. We did. This vertex right here is 1/3 comma, negative 1/3 comma 0. And this one is 1/3 comma 0. Then we were asked to find the foci. We did. The asymptotes of the hyperbola. We did. And sketch the graph. We did. Any questions?
So when the
Yes?
hyperbola is the other way, when it's on the
Yeah, let's
the
look
y-axis
at
side?
one.
Yeah.
Yeah. Let's look at one. For example, you can choose one from 21 through 26, so we can discover the equation, or we can go back and work on a problem from 9 through 20.
Can we do 23?
Yes,
Yeah.
23 indeed. So in 23, we are given a graph. I'm copying the graph. I see that the hyperbola crosses at 4 and negative 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And we are also given a point on the hyperbola somewhere as 3 comma negative 5. So this is 3 comma negative 5. This is negative 4. This is 4. And here's the graph. So let's see what we are asked. Find the equation of the hyperbola whose graph is shown. Since the hyperbola is on the y-axis, I know for sure that it will look like this.
Oh, okay.
What do I know from A and B? Because these are my only variables, or unknowns, right? Once I have A and B, I'm done. I found the equation of the hyperbola. Which one do I know?
Y.
So A and B. So X and Y are the variables of the hyperbola.
Yeah.
But what I don't know, or my unknowns here, are A and B.
Right.
So which one do I know for sure?
We know A.
Yes. And if I know A, then I know A squared as being,
16.
that's it. So what I know so far is this. And now I have to introduce this. How do I introduce that? What does that mean? And this is nothing connected to A or B. This says this, that whatever equation you come up with, make sure that this point verifies it. Because the point is on the hyperbola.
Right.
So once I have the equation,
You can check it.
that point has to verify, or the other way around. Once I have the point must verify the equation. And that's how I determine the B. So, what do I write?
So we have 3. So I would say, we say -5 squared,
Very good, which is
25.
over 16 minus
3 squared, 9.
over,
3 squared,
good,
21.
that's it. The point must verify the equation. Like, for example, if I have a function, and if I say this point 2 comma 1 is on the graph, then you have to say immediately f of 2 is 1. Here, I don't have a function. So it's two functions, right? So in this equation, I am basically told that these coordinates have to verify it. When x is 3, for sure, y will be, when x is 3, for sure, y will be -5. So I'm using the point to determine B.
So any other point on a calculator, like
We'll have to do the same thing.
if they gave us -3, -5.
Yes.
Well, yeah, we get the same thing because it's over squared.
Yes.
If we got like 3.5, -7. It
Yes,
should come up with the same answer.
exactly.
Yeah.
Exactly.
Okay.
Good. So how do I solve this equation for b? What would you recommend first? And then I'll tell you what I recommend.
Add 9 over b.
Yes, of course. I'm going to move this term, and I'm going to move this term, of course. So 25 over 16 minus 1 equals 9 over b squared. Of course, that will be my first step. Then I deal with the left-hand side, which is over 16. So 25 minus 16, we know that already is good. So, true. Let me just show you a little trick. Here's my little trick. Two fractions are equal, and they have the same numerator. What has to happen? Can I have here 15?
Yeah, it's 16.
Of course. There is no other way. But remember what I said. Two fractions are equal, and they have the same numerator. What has to happen?
The denominators have to
That's it. You don't have to cross multiply. You don't have to remember the little trick. But this is always true. But if I have here 1 and here 9, no, my trick doesn't work. So two fractions have to be are the same, and if they do have the same numerator, then they have the same denominators. Also, if two fractions are equal and they have the same denominators, what has to happen? The numerators have to be the same. So now I have the equation. I have y squared over 16 minus x squared over 16. Oh, look at that. Which means it's still on the y-axis. However, the center box is a square, which is very possible. Okay, let's choose another from 31 through 42. Which one?
31 to 42.
31 through 42. And then I like to look at the parabola. And after that, they shifted conic sections. Which one?
36.
36. Okay, in problem 36,
Oh, I'm sorry, no, not that one.
that's fine. Which one?
37. Sorry.
37 it is.
Or the one where they give you the Fossae and Asymptotes.
That's fine. 37. So we're given the foci as 0, comma, bless you, plus or minus 8. And the asymptotes are y equals plus or minus 1/2 x. Find an equation for the hyperbola that satisfies the given conditions. What have we learned from the foci being one of them, one focus 0, comma 8, and the other one 0, comma negative 8? What have I learned from that right away?
That the linear axis is on the bottom.
Yes. Very good. I don't have to graph anything. I just like to see it. 1, 2, 3, 4. So 2, 4, 6, 8 right here. 2, 4, 6, 8 right here. So this is F1 and this is F2. And this is 8 and this is negative 8. Agreed so far?
Yeah.
So that's the information I have from here.
Yeah.
I also know that c squared is 64. And I know that 64 will be a squared plus b squared. Once I know this, I know that y squared over a squared minus x squared over b squared will equal 1. Because the transverse axis is on the y-axis. So I also know that, yes, so 0, 0, when x is 1, y is 2. So this
You
is,
have your third lines are 2 each, so it'd be 1 down from that.
Oh, thank you, thank you, thank you. So right here.
But
So
it'd be at
the
second-
height,
it'd be at the first line.
the height is 2.
Yeah.
So the rise is 1. The rise is 1.
All right, rise is 1.
Rise is 1.
That's 2. Yeah.
Yes.
No. Yeah, you're not actually.
Right. So rise is 1.
Rise is 1.
Good.
Wait, no.
So
Rise,
1, 1, and 2.
Yeah,
Yeah.
I agree.
Very good. Thank you. So that says to us that which one do I know? So this is 1 and this is 2.
Yes.
So 1 and 2, which means 1, 1, right? So this is 1 and this is 1. So 1 squared, so this will appears to be 1. And this will be 2. 2 squared, this appears to be 4. However, I have a problem.
It doesn't work out.
Right, because 1 square, 1 plus 4 does not equal 64.
Right.
So this, the top and the bottom are different numbers, not 1 and 2, but a ratio of 1/2.
Right.
So the top will be A. So A divided by B equals 1/2. And now I have the 2 equations that I need. 2 equation? Yes.
Can you,
Yes.
okay.
So when we look at a box, yes. Let me just show the box. So y equals 1/2 x. It means that this ratio, this over this, is 1/2. But it doesn't mean that A is 1 and B is 2. It does not. It only says that A over B is 1/2.
Right.
That's all it means. I do have another equation, which is A squared plus B squared equals 64. This is a system of 2 equations in 2 variables. From this system, I have to solve for A and B. So, what would you recommend we do?
Substitute.
Exactly. Yes. So substitute for the one that doesn't come up with a fraction. So if you say A, then I will have to divide by 2. If you say B, B is twice A. I prefer that. It doesn't really matter. It's not such a sophisticated calculation. So then I have to replace B by 2A. So then A squared plus 2A, everything squared, equals 64. So A squared plus 4A squared is 5A squared equals 64. So A squared equals 64 over 5. Now I have to determine B. I don't really care for B. I do care for B squared.
Right.
So I'm going to square both sides. So B squared equals 4A squared. So then B squared will be 4 times this. After we are done, we're going to go back and check everything. So the equation appears to be y squared over 64 over 5 minus x squared over 256 over 5 equals 1. For now, we claim that this is the equation. So we have to go back and check two things. We have to go back and check, we were given the Fossae, and we were given the asymptotes. So as if I start from scratch, this is my equation, I want to find the Fossae and check that I get plus 0, comma, plus or minus 8, and determine the asymptotes and make sure that I get plus or minus 1/2 x. Okay? Good. So this is a squared. So a squared equals 64 over 5, which means a equals 8 divided by the square root of 5. B squared equals 256 over 5, which means that B equals, is it 256? Yes. 16, the square root of 5. Okay. I'm checking the asymptotes, plus or minus. The height is a over b, x. So y equals plus or minus. The top is 8 over the square root of 5. And the bottom is 16 over the square root of 5, x. I'll simplify, and then I get 8 over 16, which is 1/2. So y equals plus or minus 1/2 x, and this is a check. Now I have to determine c squared as being a squared plus b squared because I want to check the Fossae. Any questions so far?
No.
So c squared equals a squared, which is 64 over 5, plus b squared, which is 256 over 5. So c squared equals, that's 0 and 1, that's 2, is it 320?
Yeah.
Okay, then c squared is 64.
Mhm.
And when I take the square root, I get, yes, plus or minus 8. So then f1 is indeed 0, comma, negative 8, and f2 coordinates for f2, 0, comma, 8. Does it make sense?
Mhm.
Weird numbers at first, but everything works out quite beautifully. Thank you for picking this one. It was interesting. Okay, any questions? Any questions?
So for the equation we write.
Oh, we already did.
Oh.
We wrote the equation,
Oh,
and then we checked it.
So, is it okay to leave it in that form, or would you?
You can flip it if you want, yes. So you can write 5y squared over 64 minus 5x squared over 256 equals 1. You can. This is what I really need because that's how I identify a squared and b squared. From here, I have to divide it. Good, other questions?